Well, here's something interesting that I find. If you look closely, you'll see that this is actually not a single piece of plastic. There is a line here splitting this part and this part of the plastic. And you can see the line stretches through here and to the bottom. So it might mean that this may come out first, like this, and then this may come out in some other way. Maybe there's a screw holding it down, but it's not accessible unless I first disassemble this part. Okay, after some prying with a screwdriver, I am able to get the keyboard loose. And yeah, it is two parts. And this part is kind of, come on, detachable? You can see it's like semi-detachable, but I won't use this thing with the keyboard detached because these ribbon cables, they are extremely thin and fragile. And here we can have a peek at the motherboard. So I haven't disassembled this further, but I wouldn't be surprised given how the motherboard looks. And the fact that there's a cartridge port here, that this is actually a Z80 plus TMS9918 motherboard, and presumably MSX compatible. Another interesting fact is that this seems like a switch mode power supply, because I think this is some like iron oxide core. I think that's how it's called. And it's not the typical iron core transformer seen in linear power supplies. Come on, get a focus. Here we go. And I think we can just open this. Oh my god! What is that? That's a normal transformer. So what is this? Is this just a filter inductor? I'm wrong. And I'm wrong about the video chip too. This is a MC6847. The exact same video chip as the Tandy color computer. So there's no way this can be MSX compatible. Uh-oh. Caution. There's a caution message here. What does it say? Caution, IC sockets direction. And there's an arrow pointing this way. So what? Aren't all the ICs lying this way? Ah, I know. It's like if you read it this way, you can read like all the text, so you don't put it backwards. If you cannot read the text on it, or if you see the text upside down, it's wrong. That's kind of confusing, but also clever. And this is even crazier to me. You can see this is HM6264 SRAM, and this is also SRAM, and this is also SRAM. So these are all SRAMs. I think this is some ROM. It's called Manager V1.2. Guess we had some interesting names for our BIOS codes, right? Or kernel, if you are a Commodore guy, right? So, or Monica, if you are a hack guy. I will talk more about the hack in the later in this video. And this is a Z80 CPU, kind of standard, but this means that this is neither an MSX clone nor a Tandy Coco clone. This is really an in-house design by Chinese engineers. It is kind of crazy. And as you can see, it has some dedicated video RAM here, just beside like the video chip. And this is also, come on, get a focus, get a focus. HM6264. I guess they just have a lot of these 6264 chips lying around. And these chips are not cheap. There's a reason why commercial products use DRAMs, because they are cheap. These chips, they are 8K each. And they cost significantly more back in the day than 64K by 1 DRAM chips. And they hold the same number of bits. I guess with the price, with the money, you can buy these chips. You can buy like 8 64K by 1 DRAM chips and build a DRAM system. It is easy with the Z80 CPU because it has internal RAM refresh circuitry. So I really don't know why the SRAM chip is chosen. I have a theory though. Oh, you can see here is the Z80 CTC. I have a theory though. Because the TP design team, they come from the SBC world. They come from the single board computer world. And in that world, people kind of think differently because there's a need to single step the CPU and bring the clock down and trace what is happening in the CPU. And sometimes you don't have a debugger and you need to look at those values on a real physical screen or LEDs showing the address and data bus. That means DRAMs will lose their data once you do that. So I guess they just have more experience with SRAMs. But then we come to this cartridge port. If this is an in-house design system, then what is this cartridge slot for? There are no cartridges for the TP805. Maybe they thought that this computer might have caught a bigger market. So they thought that there would be software houses producing games and productivity software for the cartridge of the TP805. But given that they're competing with DRAM designs, even if they save all the screws from the chassis and use a giant old transformer to save a few bucks by adding more weight, I don't think this will be a very competitive product. So over here we have the TVUF. I guess it means UHF, maybe. Or is it actually RF? I don't know. And here we have CRT, which is maybe composite. And over here we have a header that says wide. I guess it's video, but the silk screen got obstructed by the printer port. 5-volt ground and output. What kind of output? Like sound output? And over here, oh, there's actually an arrow pointing to the right side of the socket. Over on this corner of the board, you can see a header says load 5-volt reset GN, I guess it's ground, MON, and hold. This header actually goes to keyboard, so I guess it has something to do with those LEDs and buttons. And over on the power supply, you can see the TP logo here. And here it says TP805 LSPS. Linear S power supply. What is S? I don't know. It's a version B89. This computer may be produced in 89, RP11. Looking at the date code of chips, we have chips from 1988, 8842, which is close to 89, but we also have chips from 1986, and the CPU is actually from 1983. A lot of the 74LS series logic is actually produced by some Triangle company, which, as far as I know, is a domestic producer of logic chips. So they don't have a date code. Here we have an 88 chip. And the video chip is actually produced in, I guess, in 1983. So this board has a wide range of ages of chips, especially when it was produced, because nowadays like 83 and 89 doesn't make a big difference, but back then these are 6-year-old chips, so maybe they are just using leftover chips to produce a cheap product or something, because 1989 we are still at the beginning of the computing age, while the rest of the world is moving on from 8-bit system to 16-bit system. So it might not be a stretch to think that they just take some leftover parts and build these computers. And over on this corner, we have Beijing Polytechnic University. So it's actually produced by some university instead of a business corporation, which is fairly common in China back in those days. We were just moving on from planned economy, and advanced research in computers done by the commercial sector was not a thing back then. I just keep discovering new things. Just beside the TP805 giant silk screen marking, we have Beijing Polytechnic University and Rev C.86NX. So probably this revision of the motherboard is produced in 1986. So it may be produced for 3 years, but in small quantities so that there's not a lot of units left. And here we can confirm that this is indeed a ROM cartridge. I thought it was an MSX compatible cartridge and wanted to compare the pinout, but I guess this is not really possible with the MC6847 chips over here. Hey, what happened to this pin? Cannot bend it back. I'll do that off camera with some more professional tools. Over on the cassette port side, we have some chips and a relay that says relay. Well, who would have thought of that? I thought the discoveries are over until I flipped it. On the power supply, we can see that this power supply is actually fused. I guess it was mandated back then and probably now still. And the fuse is actually protected by a plastic shield of some kind to prevent people from just touching it and getting contact with live voltage. And probably shield this fuse from shorting to some random components placed next to it. I like this design actually. And looking at these caps, they seem to be in good shape, but they also have this bizarre X-shaped like pressure relief pattern stamped on top of them. I've never seen patterns like this anytime before. And the heatsink of this transistor / regulator seems to be kind of off, but it's actually very solid. It's screwed in there. Although the whatever is in there is actually kind of fiddly, I cannot just turn it back into place. Oh, another thing I forgot to show is that this machine runs off an 8 MHz crystal, which probably means that this Z80 actually is a Z80A, which is capable of running at 4 MHz, actually runs at 4 MHz instead of the normal 3.58, which kind of makes sense because this computer is produced here in China and we don't use NTSC calibers, so we don't need that frequency in the computer. So why don't we just run our computer a little bit faster? But that may also mean that this computer has an asynchronous CPU and video circuitry, because the 6847 runs at a different frequency. And that's what I think. So, is there another crystal here somewhere? Or do they manage to figure out a way to run the video circuitry off the main crystal? Yeah, I'm not really sure about that. If you have some ideas, please put a comment in the comment section. But that also means this is probably the end of this video, because without the power cord, I cannot power this computer up, and I don't know how I can get a video from this machine. Probably I can solder a wire or I can get a 2.5mm plug, but I don't have them at hand for this video. And one final thing I would like to show is this buzzer here, or beeper. I think this is actually a piezo speaker instead of just a beeper. They are kind of interchangeable terms, but this one seems a little bit beefier, and it is put here in place of an actual speaker. I think you can play some tunes with this buzzer or speaker, but normally I guess it would be just beeps. Maybe I can do some interesting things with this computer, because I don't know, maybe they have a basic for it, right? If these 4 chips are together, I think they are the same size, which means they have an 8K ROM, which is not really enough for basic, but you can squeeze one in there. It's not that big a deal, so never say never. But again, I cannot do that in this single video. So that's it for this video, and bye for now. See you in the next video.